Hey guys, today I'll be doing partial derivatives. This is part 2. We're continuing from the previous video where we have the explanation of partial derivatives. So this is just additional practice questions where we'll be looking at the partial derivative with respect to x, the partial derivative with respect to y, the partial derivative with respect to xy, and the partial derivative with respect to yy. And we can have the partial derivative with respect to zxx. Now, please, before I begin, don't forget to subscribe if you're not a subscriber and like my videos. Let's get started. Here we have a function z where we need to find the partial derivative with respect to x. So we have 3x cubed that we can differentiate. So multiply 3 times 3, that gives us 9. Then we subtract 1 from the power, so that gives us 2. Because 4 ln y is a function of y, that will be 0. So all of this will just be 0 because it's a function of y. Here we have an x on the exponential, so we treat the y as a constant. So we have minus 3y. When we differentiate the x, it becomes 1. Then we rewrite the exponential, which is e to the xy. Now we can also do the partial derivative with respect to y. So we're going to treat x as a constant, so that is 0. We differentiate ln y, it's 1 over y, so that means this is the same as 4 over y. On the exponential, we're differentiating y, treating x as a constant. So differentiate the y, we'll have x, so it's minus 3x, and rewrite exponential e to the xy. Just remember, if you're having issues, you can always look at the previous video on partial derivative. Now here we're going to find zxx, meaning we're going to differentiate twice, but we already have the partial derivative with respect to x, so we just need to differentiate this once more with respect to x. So 9x squared becomes 18x, because 9 times 2 is 18, and subtract 1 from the power, so it's just x. Now we're differentiating with respect to x, so 3 and y hold as a constant. Differentiate the xy, that's a power, so it becomes y, and y times the minus 3y gives us minus 3y squared. Then rewrite e to the xy. Now we can also find zyy, where we're finding the partial derivative, but we already have the partial derivative with respect to y. Now rewriting 4 over y as 4y to the negative 1. Now differentiating this, minus 1 times 4, that's negative 4. Then y, subtract 1 from this, so you have minus 2. Then we differentiate this part, which is the xy. So we have minus 3 to be x squared, because when you differentiate xy, the y becomes 1. So that is how we have x times x gives us x squared. And rewrite e to the xy. Now we're going to show that the partial derivative xy is the same as the partial derivative yx. When we have zxy, we're going to look at zx. As you can see, I'm just looking at the part where you have the exponential times minus 3y, because we're differentiating zx with respect to y. So the 9x squared, when you differentiate that with respect to y, it becomes 0. So looking at the part where we have minus 3y e to the xy, with respect to y, we assign minus 3y to be u, and e to the xy to be v. We're doing product rule because we have two functions we multiply side by side. So this is two functions. So we find out what is u prime with respect to y. So we have minus 3. Then we differentiate v, so we have v prime. So we differentiate the y, it becomes 1. So we'll just have an x in front of the exponential and rewrite e to the xy. So it means zxy, which is the partial derivative, is, now we can just do some cross multiplication. That's the easiest route rather than writing out the formula. So minus 3y times x e to the xy becomes minus 3yx e to the xy. Then we multiply e to the xy times minus 3, so that is minus 3 e to the xy. Now we need to find zyx, so we go to the function y, zy, because we already find the partial derivative with respect to y. Now I have zy, but I'm differentiating with respect to x. So again, the 4y to the negative 1 will be differentiated with respect to x to be 0. So that is why I have this side of the function being differentiated. Again, I'm going to assign u to be minus 3x and v to be e to the xy. Now finding out what is u prime, we differentiate that with respect to x. So we have minus 3. Then differentiate v to have v prime. So remember we're differentiating x, so the x become 1, so it's just y that will be in front of the exponential. Then you rewrite the exponential, which is e to the xy. So now we're going to multiply these two together and then the next two together. So we have zyx is equal to minus 3x y e to the xy, and multiply these two together, so we have minus 3 e to the xy. Now as you can see, we're having the same thing, so therefore prove it. Now this next example, we're going to show that zx minus 2zy is equal to y times z. So we have to look at the function that is given and we need to find out what is zx, and we have to find out what is zy. Then we're going to substitute and prove that left is equal to the right. So let us look at finding out what is zx. So we are finding the partial derivative with respect to x. So differentiate x squared, we have 2x. Differentiate the x, so it become just plus y because x is 1. Then you rewrite the exponential that we have here, which is ex squared plus xy. Now we're going to look at the partial derivative with respect to y. So we're treating x as a constant. So where we have x squared, it is a like a number. So you know when you differentiate a number, it's 0. So when you differentiate the x squared, it will be 0. But on the next set, xy, when we differentiate that, we'll just have x. Then rewrite the exponential, which is e to the x squared plus xy. Now, before I substitute into the equation to show that the left is equal to the right, I will be expanding the bracket that I have here. So multiply the exponential times 2x, it becomes 2x e to the x squared plus xy. Then we multiply the y times the exponential. So we'll have y e to the power x squared plus xy. Now all of this will be replacing in the part that says show that. So I'll be replacing the zx, and I'll be replacing the zy, and I'll be also replacing the part that just have z, because it's z times y. So my zx is all of what we just expanded. So substituting this, we have 2x e to the x squared plus xy plus y e to the x squared plus xy minus 2zy is x e to the x squared plus xy. So I am going to replace that here. So minus 2 times. So what I'm replacing here represents the partial derivative with respect to y. Now over the equal sign, I need to replace what is z. So we have y times z. So z is from the question. So we have y times e to the x squared plus xy. Now, if you realize, we have this minus 2x times the exponentials can cancel the positive 2x times the exponential. So we already have the answer where these are equal. So we have y e to the x squared plus xy on the left hand side. And on the right hand side, we also have the same thing, which is y e to the x squared plus xy. And as you can see, it's the same thing. So we have proven that the left side is the same as the right side. So therefore, proven. Thank you so much for watching. Please don't forget to subscribe.